Hey there, this is Dr. B and it's time for your AP Chemistry Stoichiometry quiz. Pause the video whenever you need to and make sure you know how to solve these problems. Number one, the reaction of magnesium sulfate with table salt will make magnesium chloride and sodium sulfate. As shown below, just balance it. Magnesium looks good, see, 1 to 1. One sulfate here makes one sulfate there, that's balanced. One sodium here makes two sodiums there, not possible unless you start with two sodiums. So there it is. Does this self-correct the chlorides? There are two on the product side and we're starting with two, so that is good. This is now balanced. Question number two. How many moles of sodium chloride must be used in order to produce 42 moles of sodium sulfate? Well, for every mole of sodium sulfate, we have to start with twice as much sodium chloride, so the answer is 84.2 moles of sodium chloride are required. You can also recognize that a mole-to-mole conversion, is a one-step conversion. You start with what you're given and convert to where you need to go. In this case, for every one of these, you need two of those. A mole of sodium sulfate divided by a mole of sodium sulfate cancels entirely. The only unit left standing is the one you want, moles of sodium chloride. Question number three. How many moles of magnesium sulfate must be used in order to produce 100 moles of magnesium chloride? Recognize it's a one-stepper, a mole-to-mole conversion. Maybe you can do it in your head. Well, if we're going to make a mole of magnesium chloride, we need 1 mole of magnesium sulfate. The answer? 100 moles. Or write it down using a unit conversion, but why bother? Question number 4. Balance this equation. Vanadium does not look good. I would put a 2 there. Oxygen doesn't look good at all. The only common multiple is 10, so I would put a 5 there. And that would make, we still would have 10 there. We better put a 2 there and then change that from a 2 to a 4. That makes it 4 to 5 to 2. How many moles of vanadium are required to produce 47 grams of V2O5? Do you recall how to start these? Note that it's a mole to gram conversion. That's a two-stepper. I generally write these out. So start with what you're given, the 47 grams of V2O5. Draw your two lines and write where you're going to, which is a certain number of moles of vanadium. There's the setup. And for every 182 grams of V2O5, that's a mole, meaning we have, I don't know, a quarter of a mole or so. And any time you produce V2O5, you require twice as many molecules, or scaling it up, moles of vanadium, meaning we need about a half a mole of vanadium. Last question. How many grams of oxygen gas are required to produce 31.4 grams of V2O5? If you're being good, you are pausing this video and solving it explicitly and seeing how you're doing. Okay, the solution would be to recognize this is a three-stepper. Grams, circle it to grams. Start with what you're given, there it is. Draw your three lines. Write equals blank grams of O2, that's oxygen, it's one of the diatomics. And off you go. I mean, it's written here, so O2 also. So, there it is. We have about a sixth of a mole of V2O5. Anytime we react a mole of V2O5, we need 2.5 times as many moles of oxygen, right? 2 moles. Oh, and yeah, 2 of these requires 5 of those. There it is right there. And what does it weigh? 32 grams per mole. You need 13.8 grams of oxygen. That is our AP Chemistry Stoichiometry quiz.